One.
Welcome to this session on DeltaV System Alarms Management Solutions. My name is Kim Van Camp. I am the product manager for DeltaV, responsible for the alarm features in DeltaV. I am also a member of the ISA 18.2 committee and a member of the Industry Review Council for the AMUA 191 standard. Joining me, we have Mr. Todd Stauffer.
And I'm the Business Development Manager for Alarm Management for Exida, as well as the Product Manager for a tool called SILAlarm, and I'm also on the ISA 18.2 committee with Kim.
In the demonstration you're going to see today, we're going to be describing to you a work process, which is represented by the diagram center, the blue boxes. This work process comes from the ISA 18.2 alarm standard. And so we'll step this process through using a real alarm as an example. To the left and right of this work process, you see the various tools that will be used during the work process. SILAlarm, a master alarm database and rationalization tool set. We'll be looking at DeltaV version 11 in its Alarm Help feature. And also for monitoring and assessment, we'll be using the DeltaV Analyze products there. These products fit into the architecture as you see here. The SILAlarm tool is generally installed on a plant LAN layer, not on the DeltaV control network, which is represented in the center and lower half of the diagram. DeltaV Analyze, the analytic tool, is typically installed on the DeltaV system on an application station, as you see. DeltaV Alarm Help is a capability to present the information about an alarm to an operator, and that would be presented on the workstations on the DeltaV system, also represented in the center of the diagram. We'll also be touching on the core elements of the DeltaV system during the demo, including the engineering environment for DeltaV.
Now for the demo, what we're going to look at is a small process area representing a solvent tank with a couple of inlet flows and an outlet flow with a filter. And what we're concerned about is a high-level alarm, LIC 500. And then what we're going to show in this video is the tools and techniques for how we would deal with one alarm as it goes through the alarm management lifecycle. So we're going to look at how we can review and analyze alarm system performance following the monitoring and assessment stage in the lifecycle, including identifying problem alarms, nuisance alarms, or in this case a chattering alarm. Then we're going to load the alarm system configuration for that particular alarm into our master alarm database, which is the SILAlarm tool. Then we'll execute rationalization for that alarm following the customer's alarm philosophy document. When we complete rationalization, we'll make sure that the proposed changes are approved by our management of change board following our MOC process documented in our philosophy document. Then we'll implement the new alarm settings in the DeltaV system. And then last but not least, we'll create alarm response procedures for the operator to help them know how to respond to this alarm when it occurs.
Okay, now we're switching from the presentation slides to an actual demonstration, and we're going to begin with DeltaV Analyze. So I will proceed to the Start menu here. And in the Start menu for DeltaV Analyze, you'll see that there's actually two different links to web pages. One is to the DeltaV Analyze administrative page, and the other is to the DeltaV Analyze page. During this brief demo, we'll not be visiting the administration page, but what it is used for is to set up DeltaV Analyze for such things as definition of shifts and scheduling of alarm statistics reports. So let's go ahead and take a look at the DeltaV Analyze webpage. Okay, we've arrived at the overview page, which is the starting page. This particular page is used to do month-to-month comparisons of trends in terms of the alarms, events, and user actions. I'll be focusing on alarms today. There's a number of columns missing here because this small system that we're demoing on today is on my laptop PC, not connected to a real DeltaV system. I am going to briefly show you what the data looks like for this page for a real DeltaV system. And to do that, I'm going to actually change from the name of my laptop computer to a name of a fictional company. The data is real, but Tulsa Oil is a fictional company. Here you'll see what the data can look like month to month, and here we have a situation where month to month the customer is getting an improvement in the number of alarms. That is, they're coming down month to month, except for when they get to May and things pop up a little bit. Now, the way DeltaV Analyze works in general is point and click. So I'm going to click on that column heading for you. And we'll go from a month-to-month view to a specific month. In this case, we're looking at the month of May. And here we see the alarms for the month of May presented in terms of which units are creating the most alarms. It's possible to sort by something other than unit count. One can sort by time. And I just reformatted the x-axis label so you can see the entire month one column at a time. So this is basically the way that DeltaV Analyze works. All these pages are pre-engineered by Emerson. You don't need to build these pages. They just out of the box work this way. For example, one could focus on the critical alarms, drill in, or using the breadcrumbs, come back, perhaps focus on a particular unit, and then again using the breadcrumbs, come back. So let's get back to the main demo that we're doing for you today, and for that I'm going to switch back to the overview page and select the data that came out of this small laptop system we're using for the demo. And go there. One of the things that's important about alarm analytics is to be able to see the information not only for an entire system, but to be able to focus in on a particular operator's position. And for that, we use this feature here in the center where I can select not just all areas, but a particular name, in this case utilities, that corresponds to the DeltaV areas assigned to the utilities operator. And here we can see that there are alarms being created in these three areas right here. Now, rather than stay month to month, I'm going to focus in on a particular point of time last month. To do that, I'm going to use bookmarks, and you'll see that I have a bookmark here called Utility Alarms in the last 31 days. So I'm going to focus in on that. These relative bookmarks are really useful because one can set them up and then just day-to-day reuse them and not have to worry about respecifying a date range. So we're looking at the alarms that are coming out of this part of the plant, including that solvent area that Todd showed you in the diagram. You'll notice that I've got a number of critical alarms here coming out of this area called KVC. You'll notice also with DeltaV Analyze that the tip tools give you a lot of information when you hover over a pie chart or a column. In this case, I've hovered over that column in the red area, which is the critical area, alarm level 15 in DeltaV, and you'll see that there were 45 critical alarms. If I wanted to drill in a little bit to a given area, I can do that, such as this KVC area. And we see that all of the critical alarms are actually coming out of this control loop LIC 500. I'd like to understand a little bit more about that, guys. So what I'm going to do is look at this thing not by count, but look at this by time. And here we see that on the 27th of the month is the first time I saw these critical alarms, and then more recently here there were some critical alarms on the 17th and 18th here. I'm going to focus back in this October date where the critical alarms were, try to understand that. With a single click on that day column, now I'm looking at the same information, only now the resolution is hour by hour, midnight and so forth, until we get to 8 a.m. and we start to see the alarms going up. So this is one way to look at them. I'm going to focus on this LIC 500 in particular by selecting that module. And so you can start to get into some module details again. Again, these module details can be sorted not only by count but by time. And you see a similar view here, only for a particular module. You may have noticed these horizontal lines across the diagram. These correspond to the incoming alarm rates. And at the 10 o'clock to 11 o'clock hour, the incoming alarm rate was actually in excess of not only the acceptable level, but was actually in excess of the manageable level. These are, by default, in DeltaV Analyze, the MUA levels, although you could set those using that administrative page to a different set of names and alarm rate bands corresponding to your alarm philosophy document. One thing about this high alarm is I noticed that on this particular day it activated 27 times, the shortest time being just a 2-second activation and the average being 2 minutes. I suspect that this alarm is actually chattering. I'm also concerned that this alarm is even critical. Knowing that solvent area, I wouldn't have expected it to have been prioritized quite that high. So we're going to focus on the LIC 500 module. Now before I leave DeltaV Analyze, I want to show you one other page, and that is the alarm statistics page. The alarm statistics page serves really a different purpose than the previous things I showed you. The previous examples of drilling down were really all about analytics and trying to understand what's going on with your alarms. This dashboard here really represents a measure of the health of the alarm system overall. So I'm looking at just the day here, but for any given date range, one can look at what is the distribution of alarm priorities down here. One can look at the key performance indicators that you would typically find in your philosophy documents, such as average alarm rate, peak alarm rate, average time to acknowledge, those type of measurements, as well as a distribution of alarm incoming rates. What percentage of the time were the alarms coming in at what was an acceptable rate versus a managing, demanding, or even unacceptable rate, or whatever labels you choose to give to your alarm rate bands. In addition to looking at these statistics, these KPIs as a dashboard, one can actually create an Excel report, which I'll do now for you. The advantage of creating an Excel report on demand from this screen is you can really filter into the areas and the date ranges that you're most interested in. For purposes of periodic reporting, you would probably take this report that I'm showing you here and not run it on demand from this screen, but rather you would probably just go ahead and just schedule it on that administrative page to run automatically at the end of every day, week, or month, whatever is your preference. So here we're looking at this alarm statistics report that I've created on demand, and you'll see that we've got a date range, we've got a scope in terms of the areas covered. We have all of our key performance indicators that could be compared to your philosophy document, a little profile of the alarm timeline, the distributions, which are part of your metrics, and then you get into a top 20 alarm sources list. Now, this particular tiny demo system that we're using today just has a handful of alarms that I manually created, so you're not seeing a whole lot here. But what you are seeing here is that this LIC 500 for the solvent tank has activated 91 times on that date, an average of 4 per hour, which is quite a bit. Also further down, we have a top 20 modules with the shortest average activation time, which I use to identify chattering and fleeting alarms, and you'll see that this alarm has at the top of that list. Now, what does this list look like for a real DeltaV system? Let me go ahead and just show you an example of that. I'm looking at that same system we were looking at online a minute ago. Now we're looking at nearly a month's worth of data that was given to me for this system. And you'll see that we have an average alarm rate of 16 per hour. There was a flood. There was a peak 10-minute period where there were 207 alarms in a 10-minute interval. You've got a profile for this particular customer's data, and you'll notice that on one particular date here, they really had a problem in the sense that they had a lot of alarms. These alarm priorities here are the names that were given in the DeltaV system to the alarm priorities. There's no need with DeltaV Analyze to configure these, the DeltaV Analyze products made to work with DeltaV Analyze, and it already knows how to look up and report whatever the alarm priority names are in the system. Here's a distribution for this particular customer, and I would say this customer is not in horrible shape. They certainly don't meet the profile that one might want to have for the incoming alarm rate targets. 6% of the time they're at an unacceptable level, but I've seen systems that are much, much worse than this. Also notice here in their top 20 alarm sources that if they were to take the top 1, 2, 3, 4, 5, 6, 7, the top 8 alarms and address the alarms that are coming from those top 8 modules creating those alarms, they would have eliminated a full 50% of all the alarms coming into this system. And that's a very typical thing where just a few alarms will create the majority of the alarms. Also in their top 20 list of shortest average activation times, you'll see that at the top of the list we have one particular alarm that activated 12 times for a total sum of 11 seconds, not even being an average of 1 second on. So clearly that's an example of a shattering or a fleeting alarm. To complete the report, we have these modules that are the alarms that are on the greatest length of time. That is, these are stale alarms, probably indicative of an alarm that is not appropriate for a given process state. That would suggest something that needs to be addressed in rationalization to do some state-based alarming there. We also see alarms that are most frequently suppressed by the operators, alarms that have actually been disabled perhaps by a supervisor, indicating maybe alarms that should have been taken out of service altogether, and then our profile of the highest bay. So we're going to leave this now, and in fact we're going to actually leave DeltaV Analyze at this point, and we're going to focus on that LIC 500 and continue the demo that we had started for you. So going to DeltaV Explore, this is the heart of the engineering environment for DeltaV. That area KVC was throwing the most alarms, and within that you see there is this LIC 500 module. I recall that the high alarm was actually the one that was generating most frequently. I expect that it might be shattering. So I'm going to just take a look at its properties. And there's a couple things here that strike me about this alarm. First of all, it's got an 80% limit, which is, I know, the default for a high alarm. Chances are this alarm has never really been given close attention to determine a proper limit. There's been no functional classification assigned, which would have happened during rationalization, so I know this alarm was not rationalized. There's been no alarm help provided to the operators, and it's got a criticality that's high, a priority that's higher than what I think might be appropriate. Also, under advanced settings, we'll see that there's no shelving going on here. This thing has the DeltaV default of 999 days here, so I suspect that we're not doing shelving with this alarm. If it is a shattering alarm, that would suggest that maybe the hysteresis on delay and off delay weren't properly set. Let me just take a quick look at those. And as I look here, I see that the hysteresis for this high alarm was set at the default of 0.5%, which may not be enough for a level loop such as we have here. We also have 0 seconds of off delay and 0 seconds of on delay. So this particular alarm could indeed be a shattering alarm. So the next step is to actually have this alarm, this module be rationalized. So let's go ahead and begin that part of the work process, rationalization, by getting this module's information out of this engineering environment and over into the SILAlarm environment. So to do that, I'm going to use a standard feature of DeltaV, which is an export feature using bulk edit. So I have highlighted the particular module I want to export, and I could just as easily have exported the whole area, or for that matter, all the control strategies across the system, but I'm going to be very focused in this demo and highlight there, and do a file, export, user defined. I'm going to step through here to actually select all of the alarms within or all of the modules. In this case, it's just one module. Now we're asked for a format specification file. This is a template for actually doing the bulk export to know which fields to bulk export. I'm going to browse, and you'll see here that we have a series of these format files that have been specifically designed for use with SILAlarm. I'm going to select this one that relates to process alarms as opposed to hardware alarms or device alarms. I'm going to open that. Now that we have a format file, then the next step is to actually create a data file. One doesn't exist, so I'm going to give it a name. I'll call it LIC 500 so that it'll be easy to spot when we get into the rationalization process. Click on the next step and click on the export here, and we'll see that we've actually had a successful export. So what we're doing here basically is bringing the alarm out of the engineering environment of DeltaV, bringing it over into the rationalization environment. So I think at this point here, I'm about ready to turn over control to Todd, such that he can carry through with the balance of the demonstration for you here. So let me just turn control over to Todd.
Okay, thank you, Kim. While we're getting lined up here, just wanted to say the DeltaV Analyze tool is great at creating actionable results that we can take care of here during the rationalization process. Today, what we're going to focus on is the chattering alarm that was identified in Analyze, but certainly many of those other issues that you pinpointed in Analyze we could address through the rationalization process as well. So here's the SILAlarm tool that's going to act as our master alarm database as well as guide us through the rationalization process. The first thing we want to do is check to make sure that the settings in our tool match the rule set that's defined in the customer's alarm philosophy document. So one of the critical things we want to look at is the prioritization scheme that's defined in the tool and make sure it matches. So here we can see we have 4 priorities defined: log, advisory, warning, and critical, corresponding to the defaults in DeltaV, where log is not presented to the operator. So that matches up. Let's also look at the descriptions of consequences and impacts. And philosophy defines a consequence matrix of 4 columns by 3 different impact categories with personnel, environmental, and financial. And that matches up, and we can see here that there's individual editable descriptions for each box in that matrix. And that does also correspond to what's in the philosophy document. So let's make sure the prioritization grid is completed. And for that matrix of 4 different potential consequence severities and 4 different operator urgency levels, we have assigned the associated priority for each cell. And yes, that does match up with what's in the philosophy document. So we should be good to go from a alarm prioritization. Now for this particular customer, this particular philosophy, they've decided that system and instrument diagnostic alarms should not be presented as alarms to the operator. They should instead be treated as alerts and presented and modified or sent to the maintenance department. They'll be available for the operators to see, but they'll be segregated. That information will be segregated from the alarm information. So we're going to define 3 different priorities of alerts: critical, warning, and advisory. These would probably correspond to priority numbers 4, 5, and 6 in the DeltaV system. So that's set up. Next, we want to look and make sure that the classifications are defined to match up with what's in the philosophy document. We've got 6 different classifications defined. We could add or subtract from that to match up, and that does. And last but not least, since Kim said that he suspected this was a chattering alarm, we want to review the recommendations for alarm deadbands and on-off delays. And we can see here that the defaults have been entered, and they correspond with what's in the alarm philosophy document as well. So it looks like we're ready to begin. We'll close the settings and call up our master alarm database. And I can see we have 180 alarms in that database right now. And if I scroll through that list, I don't see the LIC alarm that Kim mentioned, so it must not be in here. So we will import it into this database. So we'll click on the Export Import Alarms. select and browse for that file, and there I see it. He put it on his desktop, so that's got the alarm information for LIC 500. So we'll select that. We have a couple of prompts to enter. Save my project. I do want this information to be loaded. Now I need to think about, do we want all of the alarm conditions from this control module, even the ones that are not enabled? I don't think so. I think we just want to rationalize the existing enabled alarm conditions. So that's all we're going to bring in. Next, it asks me whether it wants to do a one-for-one comparison between what we're importing versus what's in the database to look for alarms that are missing. And we don't want to do that in this case because we're only importing from one control module, alarms from one control module, not the whole entire configuration. So we'll skip that comparison and proceed with the import process. It's asking me to define the name of a changelog file. It creates a changelog every time it does an import. So now let's look at the results. The change list shows me that there were no modifications made to the alarms that were already in the database, which is what I would expect. But let's click on the Additions tab, and we see that it has added the new tag, LIC 500, and it's brought in 3 new alarms. A PV bad, a low, and a high. So we should have added 3 alarms to our master alarm database. So let's close our import. And we'll look and we see in the top heading that the number of alarms in the database has increased by 3. Now it's up to 183. So let's find the LIC 500. We could scroll through, but if this was a big database, that would make it hard to find and hard to work on. So let's actually filter it. So let's set a filter to say, show me the alarms that are only from LIC 500. And I really like to use this filter during rationalization because it allows me to segregate alarms by logical groupings, because then I can apply the results from one alarm to many other alarms, and that helps me get through the rationalization process as quickly as possible. I can actually copy the results from the rationalization results from one alarm to another. So being able to filter really helps me understand what I'm looking at. So in this case, we have our 3 alarms. I'm going to select the high alarm and begin the rationalization process. It's going to guide me through step by step. And first, what I see is the information that's been brought in from DeltaV, such as the engineering range. It's 0 to 100. Looks like it's a 100-foot tank. This is actually a PID loop, so that's good to know. The next, I'll move on, and it's given me an opportunity to record any safety implications to this alarm. So I'm going to look at the LOPA analysis, the layer protection analysis, and the HAZOPs that were done for this plant, and in particular for this unit. And I do see that this alarm was actually identified as a safeguard in a HAZOP. So I'm going to record that information so that we have a cross-reference so that we can always go back and understand where this alarm came from and what its significance is. So we've got that recorded. Next, we're going to move on to determine whether this alarm is really legitimate or not by first addressing what is the potential consequence. For this alarm, the tank, if the operator does not respond to this alarm, the tank will overflow. The solvent tank will overflow, and that will result in a chemical release. So we're going to record that consequence. And then as part of this rationalization process, this is a multifunctional team that's involved in recording this information and making these decisions. So we have one of our best operators involved, and he's helped us determine or document what the likely causes would be for this particular alarm. So we're going to take that information and document that as part of the rationalization process. He's also told us how he would respond to this alarm, the corrective actions that he would take. So we're going to record that information. And you can see this is kind of a knowledge capture process, documenting what your best operator would do in response to an alarm. So in addition to accomplishing rationalization, we're also doing knowledge capture. And then he's also told us how he would confirm that the alarm is legitimate and troubleshoot and determine what the actual situation is. So we'll record that information. So now we got everything, and based on what we see, it's got significant consequences. We've defined what the operator's supposed to do. So yes, this is a legitimate alarm, so it's supposed to be there. Now, Kim mentioned that there was no alarm help defined, so we want to check the box so that's created. And what that'll do is take this information for cause, consequence, corrective action, confirmation, all this good information that our best operator helped define, and we'll allow that to be transferred to DeltaV and then populate the alarm help screens. So every operator, no matter what shift, when this alarm occurs, they'll be able to see what the best operator would have done in response to that alarm. So I think that's tremendous operational value. So now let's look at prioritizing this alarm. We are going to assess the consequences in the area of personnel first. In the event that the alarm is not responded to and the tank overflows, there are people in the area at all times, so this could result in some injuries. So we'll do our assessment using these descriptions that essentially came from the alarm philosophy document from the consequence matrix. Our experienced operators said they would expect that they would have about 5 to 15 minutes to respond. We enter that information, and our prioritization matrix says that this alarm should be a warning priority, which is interesting because in the DeltaV system, this is set as critical priority. So Kim's questioning of whether it really should be critical was legitimate based on this analysis that we've done of the consequences, the potential consequences, and the amount of time the operator has to respond. I would say that this alarm should not be critical, but should be warning instead. So now let's move on to the classification step. And this alarm comes from a HAZOP and impacts personnel safety. So we're going to select those classifications. Classification allows us to group alarms together that have common requirements for testing, training, and MOC. So this will make it really easy to find alarms like this one that come from a HAZOP or impact personnel safety. And probably we'll want to make sure that they're highlighted in our testing plans to make sure that this alarm is tested at a pretty good frequency every 12 months or so. Next, we want to look at the alarm limit, and I can see that right now it's set at 80 in the DeltaV system, which I know is probably the default for this control module. Now the tank is ranged 0 to 100, so it'll overflow according to these drawings when the tank level reaches 100. So that is the consequence threshold that we need to be concerned with. Now for this, we know that when the inlet valve is open, the max rate of change is going to be 0.5 feet per minute. As a standard, we want to make sure that the operators have at least 15 minutes to respond. So if we know this, so based on the fact that we know this process dynamic information, we've calculated that the alarm limit might better be set at 92.5. So we're going to copy that value and enter that into our selected set point. Now what we want to do is document the rationale for why we set the alarm limit where we did. So we'll document that we are allowing for a 15-minute response, which will help us then in the future if anybody ever questions this alarm limit or we need to determine whether it's still correct, now we understand why it was set where it was. And maybe we'll find that process conditions have changed. We've got new equipment in there that, yes, in fact, maybe this limit should change. But now we know for sure why it is where it is. Now let's look at the deadband and alarm on-off delays. And Kim had mentioned that this was a chattering alarm. And I can see that it is a level, and the deadband is set to 0.5, which I know is the default, but that's a little low for level devices. So our alarm philosophy says that we can make the deadband up to 5%. So I'm going to change it based on the fact that we were having problems with this alarm. We're going to change the deadband to 5%. We can also implement an on and off delay of up to 60 seconds. I'm going to implement 60 for off delay. I'm not comfortable with that high of a value for on delay, so I'm only going to make it 15. Next, we'll move on to suppression. Now, we've decided, in this document in our philosophy, that we want to provide the operators with the ability to manually suppress alarms that are nuisances, also known as shelving. This is much preferable to allowing them to enable and disable alarms, because when they shelve it, the alarm will disappear temporarily, but it'll come back, so it's never lost track of. So we want to implement shelving for this particular alarm. The default in DeltaV is 999 days, so we're going to eliminate that. And we're going to allow the operator to shelve this alarm for 5 minutes at a time. Also, I know that this particular unit has problems with alarms when the equipment is out of service, when the solvent tank is out of service, and many of the other alarms in this unit are actually suppressed during that state. Now, this is a pretty critical alarm because it was identified in a HAZOP, so I don't feel that it can be suppressed when the equipment is offline like the other alarms. In fact, I think we should keep this alarm. It's actually pretty important because I know the tank, when the tank is offline, it should actually be empty. So we're going to set this alarm to have a different alarm limit when the tank is offline, something low like 5 feet, which will let us know if for some reason the tank is starting to fill when we believe that it should be offline, which would mean we've lost kind of isolation to the process. Next, we can record the team that took part in the rationalization process, representing all the different disciplines here in our plant. And in this case, now we'll change the status of this alarm so we can keep track of where it is in the process. We're going to make it say that it's pending approval and that we fixed a chattering alarm that was identified in our 11/21/11 report. So that's now recorded. It's pending approval because we still need to go through our MOC board and our MOC process to make sure that these changes are authorized. But now let's rationalize the PV bad alarm. This is a diagnostic alarm. So let's just jump right to the prioritization tab because that's what we need to do for this alarm. And according to our philosophy, we've said that diagnostic alarms should be routed directly to the maintenance folks and not presented in alarm summaries with other alarms. So that means we're going to prioritize these differently. We're going to manually set their priority as dictated in the philosophy to the alert priority scheme that we saw. And we're going to set the alert priority equal to the highest priority from that tag, which in this case is a warning. And we're going to document that it's per our alarm philosophy document. So now we have completed the prioritization of this diagnostic alarm. We'll again go to our changelog tab and change its status. to indicate that it's ready for review. So now we go back to our alarm list. And at this point, we would probably go through the MOC process to say, this is an alarm that was identified as a nuisance alarm. We've gone through the rationalization process. The priority is going to change. The limit's going to change. We've defined the operator actions. So the MOC team has reviewed it and approved it and authorized these changes. So let's change the status of these alarms from pending approval to approval. It'll pop up a message and say, so we can say approved by MOC committee. We can kind of keep track of the status of our alarms, and we can say that we can see that its approval has changed from pending approval to approved, and we've recorded that it's gone through all these steps. Now that we've completed that, we want to export this alarm information so we can send it back to Kim. So we can export to DeltaV. I know this is a version 11 system, so we'll select that. We can export all different kinds of alarms. We can rationalize all data sources in the DeltaV system, but in this case we're only after process alarms. And in particular, as part of the MOC review process, they said we're only authorized to make these particular configuration changes. So we want to make sure that the only alarms that are affected here are going to be these from LIC 500. So we're only going to export those alarms, not all the other alarms that are in the database. So to ensure that happens, let's keep our filter by tag, and also we will filter based on the approval status, because we just went through this rationalization process and these alarms are approved. So now we're going to export these alarms so that they can be sent to Kim to implement in the DeltaV system. So I'm going to set a file name that he can find. Hit the save button, and that should generate a TXT file, and there it is. A little difficult to interpret without our FMT files to know what information goes in each column, but looks like we're all ready. So I'll let Kim know that he can pick up the process and take the rationalization results and bring them back into the DeltaV system so that he can fix the alarm issues that DeltaV Analyze discovered.
Thank you, Todd. At this point here, we have a approval and everything is ready to go. So I'm going to return to the DeltaV engineering environment and import that set of approved changes. So File, Import, User-Defined Format, and browse to that FMT file, which is going to take and interpret that TXT file. So I've selected that. Now with that format file selected, I'm going to browse and see that here is the file with the rationalized settings. Open that up and proceed to import it. And we have a successful import. Let's just first of all make sure that we can see what the changes are in the DeltaV engineering environment. So I'm going to again take a look at this LIC 500 here. I'll take a look at the high alarm. We will now see that it's got a new priority established, which is a warning priority. We see the limits 92.5. There's a functional classification. The alarm help has been enabled. We can see that there's now a suppression or shelving timeout of 5 minutes allowed, so operators can temporarily set the alarm aside. And all of the knowledge that was captured from the senior operator during the rationalization process is now available to every operator in the alarm help system here, including confirmation, corrective action, cause, time to respond, and then consequence of inaction. So it looks like we're good in terms of alarm help. In terms of the alarm conditioning, there were some decisions made in rationalization to use some settings there. So let's just see if they came through. Here we have the high alarm hysteresis, which was formerly 0.5%, a little low for a level loop, and here we put 5% in. And I see that there is a high alarm off delay of 60 seconds, and a high alarm has a on delay of 15 seconds. So it appears that everything is completely successfully transferred into DeltaV. At this point, I'm going to take this module and download it, and we'll take a look at the results in the so our module is downloaded. In the DeltaV system, Alarm Help is actually downloaded separately. That allows Alarm Help to be maintained without having to actually do any downloads to control modules, which is important to some DeltaV users. So we're going to go to the Alarm Help system here, and we're going to download that across the system such that it's available at any operator position. And that was also successful. So now we've moved the changes from an engineering environment to the operating environment. Let's take a quick look at that. Here we have the LIC 500, and I'm going to go ahead and actually cause an alarm to take place by taking the set point and moving it up beyond that limit. In this particular simulation, we have this set point tied back to the input. At this point, we will see an alarm, but you will recall that there is an on delay that's been established at 15 seconds. While we're waiting for that, let's go ahead and look at the detail display and look at the help that's available for that high alarm. In fact, you can see it here. We have our alarm sounding. Let me go ahead and silence the horn. Also notice that there's an indication in context that there's help for this high alarm, which is this little blue circle with the question mark, and again, here is the help. Now, if you are a user that does not have DeltaV version 11, you're using an earlier version, all of this information you're seeing here can be put using SILAlarm into a PDF file where the file name actually has the tag name as part of the file name. And it's very easy, and our DeltaV folks can help you to create a button on the space plate here where you could click on that. Let me acknowledge that alarm. Click on a button that would take you right to a window that would pop up with a PDF file that's been nicely laid out for presentation of Alarm Help for a pre-version 11 customer. So I think at this point here, we've actually completed the cycle. And so let's go ahead and end our simulation here, our demonstration, and move to the conclusion of the presentation with some summary slides here.
Okay, thanks, Kim. So, as we saw, we were able to identify a poorly performing alarm, actually a chattering alarm, using DeltaV Analyze, and then take that alarm through the whole alarm management lifecycle, the work process, a consistent, rigorous work process with checks and balances to make sure that only authorized changes are being made and then are implemented within the system. So we were able to load the alarm configuration into our master alarm database using DeltaV Bulk Edit, standard capability in SILAlarm. Then we rationalized the alarms using SILAlarm, export that information, first did a review and authorization process using MOC, then we export the information so that it can be implemented in DeltaV, and then last but not least, create alarm response procedures using the Alarm Help subsystem for the operator. So we identified a poorly performing alarm, corrected it, got the operations team involved in making it, in recording the information on how that alarm should be responded to, and then made that information available online to the operators. So thank you very much for your attention, If you'd like to learn more, please feel free to contact Kim or myself at the email addresses listed below.